Okay, welcome back, everyone. And today we're going to be hopping into a fun problem called the birthday problem. Okay? And let's just get right on into it. How many people do we need in a class to make the probability that two people have the same birthday more than one half? Okay, let's get right into this one. So that two we want the probability that two people have the same birthday to be more than one half, okay? So what does that mean? We want the probability that two people have the same, and I'll just use an equal sign, same birthday, right? And this is going to be our little birthday cake. We want it to be greater than one half, okay? So I'm just going to think about this. I'm just going to think about this from the start and the end, as I usually like to, right? And to me, the start just probably means we have one person or zero person. And the end to me feels like we probably have n people, we have a lot of people. And this feels easier to go off for me. So I'm going to start with this n scenario that we have n people in the class. We have a lot of people. And I'm just going to select one of those people from the class, okay? And we're just going to call that guy Bob, all right? So, ooh, that's a bad O. Mr. Bob. So I select Bob, okay? And now I'm looking at the rest of my people. So after I select Bob and take him out, how many people are left? There are n minus 1 people left, right? So I'm looking at Bob and I want to see what is the probability that Bob shares a birthday with, say, the person right after Bob. And we'll call that person Bob plus 1. So the probability that Bob shares a birthday with Bob plus 1 is probably equal to 1 over 365, right? Because Bob's birthday is one of those dates in the calendar. It's one day out of 365. And so the probability that Bob plus 1's birthday, is equal to Bob's birthday, then is 1 over 365. But there's not just Bob plus 1. Isn't there also Bob plus 2, Bob plus 3, Bob plus 4? And if we just call Bob the first person, then that goes all the way up through Bob, plus n minus 1, right? So there's that many people. So we're going to define an event since things are getting kind of complicated now, okay? We're going to call this event EI. And EI is going to be E sub I is going to be the event that person I shares a birthday with someone else. And so let's go back to thinking about Bob, right? The probability Bob shared a birthday with Bob plus 1 was 1 over 365. And the probability Bob shares a birthday with Bob plus 2 is also 1 over 365. And so you might be thinking, right? Other than Bob, there's n minus 1 other people. So maybe we should do something like a summation, right? Where we go to n minus 1 and we start at 1 and we summate 1 over 365, right? I mean, this feels like it should make sense. It's the probability Bob shares a birthday with Bob plus 1 plus the probability Bob shares a birthday with Bob plus 2, and so on and so forth. But this is actually not the approach we want because sharing birthdays are independent, not mutually exclusive. And this This implies mutual exclusivity, right? Which is not good. This implies mutual exclusivity. When we do a summation like this, we're basically saying, right? We're basically saying when we do summation like this that, the probability that Bob shares a birthday with Bob plus 1 or Bob plus 2 or Bob plus 3 is equal to, the addition of all of those probabilities. But that's not true. They're not mutually exclusive. They're independent. And why are they not mutually exclusive? Because they can happen at the same time. Bob can share a birthday with Bob plus 1 and can also share a birthday with Bob plus 2, right? So these can't be mutually exclusive. They can happen at the same time. Okay, and you can see how this kind of makes things trickier because, we wanted this probability of, A or B or C. We wanted the probability that Bob shared a birthday with Bob plus 1 or Bob plus 2 or Bob plus 3. But it's just not as simple as this summation because they're not mutually exclusive, okay? So this is where we have to kind of change our approach. And our approach then is going to use, all right, the complement. And I'm just going to put a period there because I can't remember if complement is spelled with an I or an E. So we're going to use the complement, okay? So if the new approach is going to use complement, then what exactly am I going to look for? So I'm going to define this new event X. And event X is going to be the event that no one shares a birthday. And let's go back to how we solved this in the beginning where we just selected Bob out from the group, right? And once we selected Bob out from the group, there were how many other people? There were n minus 1 people remaining. And the probability that Bob doesn't share a birthday with the first person is 364 over 365. And the probability that Bob doesn't share a birthday with the next person is 363 over 365, given, right, that this person also does not share a birthday with this person. And this goes on. And eventually, what we're going to see is that we have this multiplication, right? We have this multiplication happening. And it looks something like this. It's a multiplication, okay, from I equals 1 up through n minus 1, right? Because we're just starting with our man Bob and we're going through all the other people. And it looks like it's going to be something like 365 minus I over, because how we start with 364, over 365. And actually, we have enough here to where we can solve this and figure out what this is, right? So this is actually going to be, and we can start with the denominator because that's going to be easiest, right? We know that this 365 is getting multiplied by itself n minus 1 times, right? It's getting multiplied by itself n minus 1 times. And this up here, well, this is just going from 365, or it's starting with 364, and then it's multiplied by 363, and it's multiplied by 362. So it's looking like it's going to be some sort of factorial on 364, right? But obviously it's not going all the way down to 0. It's going to have to stop at some point. And the place where it's going to stop is actually, if you do some mental math, it's 365 minus n, right? Because let's think about it. If we have a group of 4, right? So we're going to go from I equals 1 to 3 because of Bob, right? And we're going to go 364 times 363 times 362, right? So then where are we going to cut it off? We're going to cut it off at 361. That's what we're going to divide by on the bottom to get rid of all the other leading numbers. And so that would be 365 minus n factorial. And so this is our final answer, right? For the probability that no one shares a birthday if we have n people. But we're looking for how many people we need for 2 to share a birthday, right? So then the probability that at least one pair shares a birthday is going to be 1 minus this, right? So it's going to be 1 minus 364 factorial over the 365 to the n minus 1 times 365 minus n factorial. And we want this probability here, right? Because this is a probability still. We want it to be greater than or equal to 1/2, but really we want it to be equal to 1/2. And, you know, when we do out the math, what we get is that n is going to be equal to 23. All right, so thanks for watching, you guys. I hope you enjoyed this one and found it kind of interesting and festive for the birthday. Yeah, see you in the next one.